Hello everyone. Today we will attempt to answer the following question: how to characterize metallic surface. To answer this question, we will propose you two solutions. But after all, why is it important to characterize surfaces? Radiometric surface characterization is essential in many modern fields, including art, industry, but also in watchmaking with the complex watch face. And this technique is a key tool for addressing today's industrial and technological challenges. Before to explain my method of characterization, I will provide you some definitions. So visual perception of an object is possible because the object reflects part of light radiation toward observer's eye. And for each material, three phenomena occur: reflection, absorption, and transmission. Here we focus on the reflective properties. And this leads us to the concept of the BRDF, but don't panic. The BRDF is just a way to describe how a surface reflects light. So the experiment was simple. The light source emits a light beam to the sample. Here we took a complex metallic surface with grooves. Then the camera captures the intensity, and the goal of the experiment is to detect artifacts by moving the light source around the sample. And this can be visualized as follows by thanks to computer coding. And here we see one colors, which indicates a significant reflection of light around these areas, around these pixels. So this is due to the surface architecture with grooves, and you see regularity. That is not concerning. And we compute the BRDF on each pixels for all angles, and we obtain three examples. The third one and the third one, we see a peak between 90 to 100 degrees. And here we have a little different peak located between 80 to 90 degrees. We compute, at the end, we compute that for all pixels, and we obtain a remarkable point, probably one artifact, and it corresponds to the peak between 80 to 90 degrees we saw before. So the experiment was simple, but the challenge is to position the sample correctly at the center of the rotation of the system to have correct results.
And to overcome this problem of rotation, we tried another method using translation. So we set up the camera and the lamp at the specular reflection, in other words, at the direct reflection, like a mirror. And then we recorded while the lamp was moving along the z-axis, and it gave us a video we cut in many photos like this, and we could then plot the intensity of each pixels in function of the photos. I don't see the curves. Okay, then we could compute the areas under these curves. And as you can see, maybe, this curve is slightly greater. So the area is slightly greater than the two other one. And the spot is a bit lighter. So it changes color. So we can deduce there is a difference of gloss. So then we mapped all these values of area of each pixel on the of the photos, and we were able to spot all the gloss variations of gloss properties of the sample, and we were able to find the same spot as the other method. However, this because we need the best resolution, we were limited to one range of gloss level at a time because of the focus and saturation of the camera. And the computation time is also a parameter which favors the BRDF method because it takes only half a minute, although the difference of computation time could be lessened by the optimization of the code. We lacked the time to perfection it to the needs of our specific question. But because the first setup, the BRDF method is way harder to install than the Gloss Scanner one, in function of your needs, we could use one of the methods in order to find gloss variations, because as you can see, we have the same spots, we find the same spots with the two methods. If you're interested in these methods, we invite you to meet our colleagues at the post session, and they will be able to answer your questions and give you details on the systems and results. Thank you.
Thank you.
Thank you very much. So, is there any question? Okay. So I was wondering, when you are talking about computation speed, so you talk about half a minute. Say half a minute for the BRDF, okay, and for gloss scanner. Oh, yes. Okay. So, and the expectation is, for example, to be able to scan many pieces that were going, okay, so. And is there any idea to speed something, or is there any idea to speed the computation?
Yeah, actually, we had a code which was used for another glass scan with other materials, and this code was not perfect. It could be optimized by. I think we could halve the time at least, and even I think with more time, it can be really optimized. But I don't know how many, because we didn't have a lot of time for this. We already had to make all the scans for our pieces.
Okay, thank you. So yes.